Ocean acidification is a process that occurs when the ocean absorbs carbon dioxide, CO2, from the atmosphere, leading to a decrease in the pH level of seawater. This phenomenon is primarily a consequence of human activities, especially the burning of fossil fuels and deforestation, which release large amounts of CO2 into the atmosphere. Here are the key aspects of ocean acidification. 1. Carbon dioxide absorption. The world's oceans act as a sink for atmospheric CO2 and store vast amounts of carbon dioxide. However, this process has unintended consequences. 2. Chemical reaction. When CO2 dissolves in seawater, it reacts with water to form carbonic acid, H2CO3. This carbonic acid then dissociates into bicarbonate ions, HCO3, and hydrogen ions, H+. The increase in hydrogen ions leads to a decrease in seawater pH, making it more acidic. 3. Lowering pH. Ocean pH is measured on a logarithmic scale, with lower pH values indicating higher acidity. Before the Industrial Revolution, ocean pH was relatively stable at around 8.2. However, due to the increased levels of atmospheric CO2, the average ocean pH has declined to around 8.1 since the pre-industrial era. 4. Impact on marine life. Ocean acidification has detrimental effects on marine ecosystems, particularly on organisms with calcium carbonate shells or skeletons, such as corals, mollusks, and some types of plankton. The increased acidity makes it more difficult for these organisms to form and maintain their shells, leading to reduced growth rates and increased vulnerability to predation. 5. Disruption of food chains. Ocean acidification can disrupt marine food chains by affecting the health and abundance of primary producers, e.g., phytoplankton, and their consumers. This can have cascading effects on higher trophic levels, including fish and marine mammals. 6. Economic and social impact. Ocean acidification can negatively impact fisheries and aquaculture, which are critical for many coastal communities. Reduced shellfish populations and altered marine ecosystems can have economic and social repercussions. 7. Mitigation and solutions. Reducing CO2 emissions and addressing the root causes of ocean acidification is the most effective way to combat this problem. Sustainable practices, such as transitioning to renewable energy sources and protecting marine ecosystems, can help mitigate its effects. 8. Research and monitoring. Scientists study ocean acidification through monitoring and research programs. This research helps assess its impact on marine life and ecosystems, predict future trends, and develop strategies for adaptation and mitigation. In summary, ocean acidification is the result of increased CO2 levels in the atmosphere, leading to the absorption of carbon dioxide by the world's oceans and a subsequent decrease in seawater pH. This process can have harmful consequences for marine ecosystems, posing challenges for both the environment and the communities that depend on marine resources. Efforts to reduce CO2 emissions and protect marine ecosystems are critical in addressing ocean acidification. Subscribe for more videos. Thanks for watching.